welcome to Q Talks. I'm a big data scientist at Qimia, and today I'd like to talk about data warehousing. First, in general, and then on AWS. The video is composed of three main parts. First, the motivation, the why question, why would we need a data warehouse, why would we want to build one? Second, what a data warehouse actually is, how does it differ from a normal database, and how to build a data warehouse. And lastly, about the ETL process, basically how to get the data into the data warehouse. What a better way to start a video than with a cliche? Data is the new gold. We all know that. Most companies in the 21st century already have an operational database. So they gather a lot of data, they try to save a lot of data from various sources into their ideally well-designed SQL database, but it could be also just a bunch of text files lying around on some storages. What they sometimes still miss is a data warehouse. So basically a way to get the data properly out, to analyze them, to get useful insights, to make business intelligence, do proper fact-based decisions, and even experiment with machine learning to push their business forward. An operational database is usually normalized in the so-called third normal form, which means it's focused on avoiding data redundancy and on fast writing of the data into the database. This unfortunately results into complicated multi-level dependencies, as we can see on the retail example here. It's not necessary to understand the full picture. We just need a few tables such as sales, products, stores, suppliers, discounts, and employees. And also the sales items that connects the products and sales. Suppose we want to analyze the total price and the total discount price of all items sold for different days, store cities, supplier countries, and employees that sold the item. We would need 6 joins, and as those are very costly operations, it would take a long time to get the response from the database, and it would be not very responsive in case we want to slightly change the question or analyze even also the total number of items sold and so on. That's why data warehouses focus much more on performance. There is usually the slower writing with a process called ETL that I'll get to in a few slides, but the reading of the data, the analysis is much faster. They achieve that by having much simpler schema called the star schema, where, as we can see here on the picture, in the center of the star there is the fact table. This usually represents one business process. Here the company is obviously interested in the sales, so it's one sale is one row. And the fact table then contains measures such as the total price, the total discount price, the quantity, and so on. To this fact table there are several dimensions connected. These are basically the questions, the source of the groupings and the filterings. Here we have dates, products, employees, and stores. Now, let's talk about the data warehousing process a bit. This is the process of designing the data warehouse. The gold standard is the 4-step dimensional design process, where the first step is to select the business process. Here we have the sales, but it could be many others. Secondly, we need to declare the grain. That means how atomic, how granular the data should be. We have 3 options in this use case. The first one is per sales transaction, where a customer comes into a shop, buys several items. They all result in just one row in the fact table. This is obviously not enough because we need to analyze also the products that the customer bought. So the second option would be per product in the transaction, where each product results into one row. We can also go more granular and have it per item in the transaction, but the source database in this case doesn't support that, so the second option is the good option. Thirdly, we need to identify the dimensions, the W questions, when, which, who sold the item or where the item was sold. And lastly, we need to identify the facts, so-called measures. These are either additive, semi-additive, or non-additive. The last one is represented by the revenue margin in this use case. The last ones are additive across all dimensions. Lastly, if there are more fact tables being developed, It could be that several teams work on the fact tables. We need to design something called the bus matrix, which organizes those fact tables and the dimensions together. As we can see here, there are 4 fact tables: the sales, the discounts, the deliveries, and the purchases. And they all use a subset of the dimensions. In the table, we can see which fact table uses what dimensions. Now let's be a little more practical and technical, and let's talk about one of the cloud options, how to design a data warehouse, this being the AWS Redshift. There are a few things that need to be thought through when designing such a Redshift data warehouse. Firstly, obviously the type and the number of nodes in the cluster. They differ in the number of CPUs, in the available RAM, or in the storage size. Secondly, when designing a schema of tables on the data warehouse, there is the distribution style. There are 3 options here. The even one, where all the rows in the tables are spread evenly across all the nodes, so each node has the same number of rows as the other ones. The second distribution style is key, where rows with the same key, with the same values in one column, appear on the same node, which is then useful for some joins. And the last distribution style is all, which is useful for some medium-sized dimensions, where the rows are copied to all nodes on the cluster, and therefore there is no data movement needed when making joins, for example, with the fact tables. The third thing is then sort keys. There are again 3 options. Single key, where just one column is used as a sort key. The compound sort keys, where several columns can be chosen, but if we choose, say, columns 1, 2, 3, and 4 in this order, and then do sorting or filtering based on columns only 2 and 3, and not the first one, there is no advantage over the single key. So in this case, it's better to use the interleaved key, where any subset of the columns can be used in the query, in the group by or filtering. Especially in the last case, then it's necessary to watch out for running the vacuum command often. When new rows appear in the table, the keys degrade and we need to re-optimize them, re-index them. So in the last part of the presentation, let's talk about ETL, the process of getting the data into the data warehouse. This can be done in several ways, either by a small SQL scripts when the data is small and the structure is not complex. But with ETLs with bigger data or more complex structure or complicated joins and aggregations, several stages or near real-time processing, something like Apache Spark can be used, can be more robust. On AWS, we have basically 2 options how to do this. Either the glue jobs, which are serverless, fully managed ETL services. So it's just necessary to define the transformations, create jobs, and set up the schedulers that would execute those jobs. However, for pipelines with higher frequency, such as an hour or 15 minutes, the glue jobs become cost inefficient. They can't properly utilize the resources that they use. In this case, it's better to invest into building an EMR cluster, which is a self-managed service on AWS, and run all the jobs on this cluster. This cluster can be started or shut down on demand, can be fully automated with services such as the CloudFormation or Boto3, which is the Python SDK on Amazon. Summing it all up, a data warehouse is essential to push a business forward in a data-driven world. We described the data warehousing process, how to design data warehouse schema, how to build the data warehouse on Redshift. We also talked about how to move the data from the source database into the data warehouse, either with AWS Glue or AWS EMR. Thank you for watching.
Qimia. To the future, together.